Okay, so we'll finish up everything that's going to be material for this week by looking at the last part of section 1.3. We already started it yesterday, so in terms of notes, there's really nothing you have to take down for steps. It's mostly just looking at examples. Yeah?
Can I sit up there so I can see?
Oh yeah, sure. Yep. There's no one there because he switched out. All right, so what we're going to see today is more of the combining like terms and variables on both sides. Whenever you put variables on both sides, that can kind of lead to some things that we haven't seen yet. Okay, some special cases that can happen. So let's look at this one.
So guys, this one right here is like someone asked, I think it was like number 2 on the homework. Number 2 is on the homework was just like this with with variables on both sides. And also example 4 we did yesterday, before we did the word problem, just like this, same kind of setup.
So first step, anytime you're solving an equation, is to what? What's the first step? Even if you don't have to do it here. Miguel? Simplify. What's my first step under simplify, Miguel?
To add.
No, not add. Add or subtract is going to be the next step. Begins with a D, a certain property we want to use. So then, distributive property. Nate, do we have distributive property here?
Yes,
that's going to be all year, you know, right? Okay. So do you have distributive property here?
No.
No, how do you know?
There's no parentheses.
There's no parentheses. Nice job. So no parentheses. Next thing, one more thing under simplify, we got to check for it. Yep, Savannah? Combine like terms, make sure they're on the same side. I don't see any like terms on the same side. Okay? Something with like terms on the same side, there you go. X's and X's on the same side. Now you have to do that. Okay. Not here. All right, so then Miguel said that he mentioned adding and subtracting. I said that's the next step. Does anyone see adding or subtracting we can do here? You've got a lot of options. But if you can try to keep the constant positive, that's always a good thing. Yeah, Matt?
So you could add 9 to both sides.
Yeah, I like adding 9 because if you add 9, it's going to keep it positive. 12 plus 9 is a positive. If he had subtracted 12, it's not wrong, but now we have to deal with negative numbers.
And you want to try to move the one of lesser value. Maybe something like what, combining positives and negatives, ignore the sign. I mean, look at the number that's bigger, ignore the sign. Take the sign of that number. For this one, you don't want to do that. Look at the signs. Negative 9, positive 12. Negative 9 is less than 12, move on.
And 12 plus 9 is going to give me, get there, 21. Perfect. All right, so this is going to be a 3-step problem. We just did step 1. All right, now we've got 2 more steps to get P by itself. Do I have any more adding or subtracting to do, or should I now move on to multiplying and dividing? What do you think, Matt?
You still have adding and subtracting.
I still have adding and subtracting. I'm not done with that yet. I don't go to multiplication and division till all the variables are on the same side, and they're not. Okay. So what would I have to do now to get all the variables on? Well, first, which side would I have to get them on? We put the numbers without variables on the right. So numbers with variables, where are they going? Angela? They're going on the left. How would you get all the variables on the left? Yeah.
You subtract 2p.
Subtract 2p. So 2p minus 2p is gone. 5p minus 2p leaves me with about Ryan. We got that. What's 5 minus 2? 3. 3 what?
3p.
3p. Nice job. So 3p equals 21. Now, last step. Now we're down to a single step equation. Gigi?
You're going to divide.
Yeah. And what are you going to divide by?
3.
3. Now we saw in homework we had one that was a decimal. If it's a decimal, use your calculator. I think we can handle that one. What's 21 divided by 3? You said?
7.
7. Now, we always want to go back and read the directions to see if it said what?
Check.
See if it said check. This one says solve, so we're good. P equals 7. If you want to check it on your own, and you have time on the test, might be a good idea to make sure you get it right. It's always nice if you find your mistake before I do, because then you get it wrong. All right, so P equals 7. Any questions on that? So that's kind of a review. That's just the basic case. You solve it, you get a single number as the answer.
But these ones are like a little more advanced with equations on both sides and stuff like that.
Variables on both sides.
Oh, variables on both
Yep.
sides, I'm sorry. We're not gonna have to, we wouldn't have you check those. You'll check the more basic ones, like the one, like, we may have you check like a 2-step, check a couple, 2 or 3 on the 1-step. We won't have to check anything like that.
So I told you that when you have variables on both sides, a couple different things can happen. One thing that can happen is what just did. You solve it,
So nice.
turns out normal. But it's also possible when you go to solve it that you end up with an equation that's impossible. There is no solution to it. Okay, so we're going to look at something like that. And then we're going to look at equations that's like the total opposite. It's not that you can't find a solution. Anything is a solution. Like any positive, negative number you can think of is a solution. So we'll talk about what those two things are called in a second.
Will there be a problem on the test that is no solution?
Yep, we'll probably give you an example of a no solution and one that has any number as a solution. And we'll show you how to solve it.
Yeah.
One thing that is important is what the equation is called if there's, basically we say an infinite number of solutions. That's called an identity. All right, so I might ask you to classify an equation on the test as an identity or not. I might say, is this an identity in one of the problems I have you solve? So an identity means that any number is a solution. How do you know that? Well, that's what I'm going to show you in a second. Okay, but an identity is when any number is a solution to an equation. Anything you think of. Okay, so let's see if we can solve this one. 4 plus 5x equals 5x minus 3. Now, it's up to you if you want to get all the numbers without variables on the same side first, or you want to get the numbers with variables on the same side. I think we should deal with the 5x first. How about Melanie? What side do you want to put all the variables on?
On the right side.
Okay, it doesn't really matter. You'll see why in a second. But let's put all the variables on the right. So she wants to move this over here. What would I do on both sides to do that?
How would you move it?
Oh, page? Well, going through our steps. Do we have any distributive property? No. Do we have any combined like terms? Nope. What's the next thing after combined like terms? The next adding and subtracting. Do you think you could add or subtract to move the 5x to the other side? Sure, which one? Yeah, what would you subtract from both sides? Exactly. So you're going to subtract 5x from both sides. What's 5x minus 5x?
0.
0. That's why we did it, because we're moving it to the other side. But now look what happens on the other side. What's 5x minus 5x?
0.
0. What's on the left-hand side right now?
4.
4. What's on the right-hand side?
3. Negative 3.
Negative 3. If you get to a step where all your variables just disappear, like they just did, then as far as algebra steps, you're done. Now we just look at that and figure out what it means.
Yeah, we're translating, right? We know like and means like translating to English, like algebra to English, and means plus. We talked about equals, right? What does equals mean? What does it translate to? What word?
Same.
Could be same. What else? Is. No, you read that instead of saying equals, say is.
4 is negative 3.
4 is negative 3. That makes sense? No, that doesn't make sense at all, right?
So what do you think? So that's not true, right? 4 is not negative 3. So what that means is, do you think this equation has no solution, or it's an identity where there's an infinite amount of solutions? What do you think? Matt?
No solution.
This is a no solution.
Once again, when it's a false statement, when you look at it, it makes no sense. That means there's no solution. That's false. 4 is -3. It's not true. 4 can only be 4. -3 can only be -3.
So if you end up with a, as Mr. Roy just said, false statement, the answer is not false. If you write false, that'll get marked wrong. The answer is what I just circled. No solution. But that's how you tell it's no solution. You get a false statement. A statement that doesn't make sense. Like 2 is 7. No, not the last time I checked. So if you end up with a false statement, the answer is no solution. And I'm going to say the exact same thing in a minute, except I'm going to change one word. I'm going to change false to true, and we'll talk about what that means. But that's the other thing.
Thinking, guys, if we go back into the problem, right? Mr. Hager said he had the +5x, and then he had the 2 variables, right? He said it doesn't really matter which one you move. Why does it matter which one you move? Why does it matter? Mary?
Because either way, you're still getting 0.
Yeah, they're the exact same number and variable. It's the exact same thing. No, they don't have, no one, you're not going to end up with a negative. Right? There's no lesser value there.
But I would move the variable first.
Yeah.
Only because if you move the 4 and the -3, then you're going to turn this into a 2-step problem. Mm-hmm. I only had to do 1 step by moving the variable first.
Mr. Hager makes a good point. Whenever you're dealing with variables on both sides, move the variable first. Alright, so when you're dealing with variables on both sides, let's move the variable first. We're going to do this next one, Mr. Hager?
Sure, is that the last one?
It's the last one. That's it. Quick notes today. Alright, everybody's good with this? No solution. So it's false, no solution. Alright? Alright, last one. So this one, it has a step that we didn't have on the 2 others. So I'll give you guys a few minutes, 10 seconds so to get that written down. And as you're writing it down, I'm just going to say to you guys, this equation has steps that we haven't used on the 2 previous to them. Yusuf already knows.
Oh, okay.
Well, you can tell me what.
Oh, like you can like use like 2 variables and like subtract them.
What do we call that?
I forgot what it is. Combined like terms.
Combined like terms, right? So Yusuf, what's the, on the left-hand side, right?
Yeah.
And tell me the sign as well, positive or negative. What like terms are you combining on the left-hand side?
+3 minus.
+3, -2, the sign to the left. Positive, negative. Yusuf, when you do that, what do you get?
I'm not sure, but give me a second.
3 minus 2. And 1. I can put 1x, or I could just put
1.
x.
Oh, you put x.
Both things mean the same. If you forget that there's a 1 there, and you want to put the 1, that's fine. If you know that there's a 1 there and you just want to put the x, that's fine too. It's entirely up to you. So 5, what sign should be there? Positive or negative? Ellie?
A positive.
Positive, right? Again, we know this is positive. It's the first term in the problem, right? But for this, when it's after another number, we have to put the sign. All right, we have to. Don't put this. Don't write anything. If you write nothing there, you might make a mistake. All right. So Yusuf, do you want me to put a 1x or just an x?
Just do 1x.
Just do an x. Okay, man. Whatever you want. Have it your way. On the other side, so this side's all taken care of. I combine these, they're done. On that right-hand side, Dylan, can you tell me the pair of like terms with the sign, with their signs as well?
4x and -3x.
Exactly. 4x and -3x. When I do that, what do I get?
X or
This is x, 1x. We'll keep it consistent with this. We'll put an x.
Remember yesterday, Mr. Roy said you're not doing like +3x.
Yes.
You're not.
When they're on this, Mr. makes an awesome point. When they're on the same side, we're not moving anything. We're just do the math. When they're on the same side, just do what the signs tell you to do. You don't have to do the opposite operation. Just do the math. There's no need to put like +3x here, +3x here. That's going to give you 7x. You don't want that. All right? Just do what the signs say to do, and you're all set. Cancel out. cancel out. Alright? What's left, Yusuf?
This one.
Just bring the plus 5 down, so we didn't use it. What can I do now? Mary?
Subtract an x from each side.
Yeah, so we're going to subtract the x on the left, right?
Yeah.
Again, like we just said in the last one, when we have variables on both sides, alright, move the variable first before you move the numbers, right? So we'll get minus x, minus x. What happens?
The x's cancel out.
This cancels out, that cancels out.
5 plus 5.
I'm not going to put zeros, it's going to screw me up. And like Ellie just said, bring the 5 down.
And bring the other 5 down.
Here's my equal sign. Here's my other 5.
But don't you plus 5 plus 5?
No, because there's an equals.
Oh.
No? I mean, if I wanted to, I can like,
Okay.
there's really nothing else I can do here. I'm done. Alright? Bethany, what do we say? We said equals means what again? What's equals mean? What does it translate to in English? Is, right? So, I'm just going to write that there. Bethany, what does it say? 5 is that true?
Yes.
It's a true statement, right? The one we had before was a false statement. No solution, right? Now, we have a true statement. So what do you think the answer is? Yusuf?
Like the identity.
Identity, right? This answer, so if a true statement,
Is it called identity or?
Well, it's called an identity, and the answer is all numbers. So the answer is any number that you want.
So it does mean like accept identity or something.
You're just right. Well, it's called an identity. Like the last one was called a contradiction, and the answer is no solution. This is called an identity, and the answer is all numbers.
It's all.
All numbers.
so what does that mean, all numbers? I don't understand. Mary?
So you can take any number you wanted, put it for x, and you
Yeah.
get the same answer.
You can plug in any number you wanted for x, and both sides will match up. Any number you want. 1,506,000, doesn't matter. Anything you want for x, and your answer will match up on both sides to be a true statement. So like Mr. Hager said, tomorrow, there may be one section of 3 questions. We'll ask you to identify one that's all real numbers or identity. So when you put your answer, obviously you do all the math. Do one that will have one that's all real numbers, one that's no solution, and one that's just a basic one solution. Just like we did right here. I know example 2 and 3 will definitely be on the reference sheet for if you guys haven't decided it yet. Alright? So today we did, again, a combined like term one. Again, we had no solution, one solution, and then all real numbers, identity. Alright? Couple things. So homework, we talked about this. The reference sheet. Alright? And we'll talk a little more about that in a minute. We're going to give you the test review. Alright, we're going to give that to you guys. So we have a little bit of time right now, you might want to start working on it. Or with the time you have left, alright? Again, remember, on the test review I'm going to give you, has like the different problems on it, the ones that you know, the reference sheet, you're going back to your notes, you're finding the examples. Alright? The test review is using your reference sheet, writing the example that's similar to the one on the test review. Alright, so it kind of works out like that.
So it probably makes sense to do the
Reference sheet first.
reference sheet first.
Again, you can only use the reference sheet on the test tomorrow. The test review that I'm going to give you, alright, it says you can use it on the test, you can't. Alright, that was from last year. Alright, so you can't use the test review, you can only use the reference sheet. And again, the reference sheet counts as, you can have both things done to get full credit for your homework. Alright? Again, the reference sheet is posted on Google Classroom. We're not giving you a copy of that. You have to go on the Google Classroom and print it off. I'm not giving anybody a hard copy. Reason being, I want you to get on the Google Classroom and use it. I know some of you guys may have directed study, some of you guys may have a learning support in your other classes. I know a lot of people here may have Mr. Anderson. I'm sure if you ask him, he's a pretty nice guy. He'll let you print it out in class if you ask him. I'm sure he won't say no. Just tell him it's from Mr. Roy. Alright? Mr. Hanson can let you do it, tell Mr. Roy's gonna kick him in the butt if he doesn't. Alright? First test tomorrow. I think 15 questions total, that's it, right? Should be okay. Extra help after school today. I won't be available today, but I know Mr. Hager will. Tomorrow morning, if you have any questions on the test review of the reference sheet, I get in my room about 7:30, right across from Cosmo, 225. If you wanna come see me with any questions, that's fine. Mr. Hager will be after school today too.